This video is going to look at factoring trinomials using what is commonly called the AC method. Your textbook doesn't normally write it like this. It does mention it a little bit, but it doesn't give a step-by-step description about how it works. Now what we're talking about is factoring trinomials of the form ax squared plus bx plus c, where normally when that a value is a 1, we don't really have to use the AC method. We can sort of just do it by trial and error. But when it's something other than 1, a 3, a 5, a negative 2, 6, 10, then we are going to try to use the AC method for factoring. So how exactly does that method work? Okay, let's start with an example. Let's start with the trinomial 3x squared plus 8x plus 4. And let's say we're trying to factor this, and we're going to use the AC method. Well, there are basically 4 steps in the AC method. The first step in the AC method is simply going to take the value a and multiply it by the value c. Now, in this particular trinomial, a is whatever's in front of the x squared term, and c is the constant at the end. So basically, for our purposes over here, step 1 is to multiply 3 times 4 and get 12. Alright, so that's our first step. The second step in the AC method is to basically look for 2 numbers. You're trying to find 2 numbers that satisfy 2 criteria. First of all, those numbers need to multiply to give you the value you just found in step 1, AC, but they also need to add to give you the value B. Over in the problem we're working on, that would mean for step 2 that we're looking for 2 numbers. They're going to multiply to give us 12, the value we just found in step 1, but also need to add to give us the value B, which in this case is the value 8. So 2 numbers that multiply to give us 12 and add to give 8. And you play around with them, and you're going to find the numbers 6 and 2 satisfy that. And there's only ever going to be one set of numbers that's going to work. So if you found 2 numbers that work, you have found the only numbers that work. If those numbers do not exist, then that just means the problem is not factorable and would be prime. So we've multiplied 3 times 4, got 12. We found 2 numbers that multiply to also give 12, but add to give 8, 6 and 2. So what do we do with those? Well, that's where step 3 comes in. Step 3 in the AC method is to now take the 2 numbers you just found in step 2 and rewrite the middle term, the second term of the trinomial. Rewrite the second term using the numbers you just found, the numbers from step 2. What that means is, for our purposes over here, the numbers we just found in step 2 were the values 6 and 2. And so what we're going to do is we're going to take and we're going to rewrite the original trinomial. We're going to leave the first term 3x squared. We're going to still leave the last term a positive 4. But in place of this 8x right here, using the fact that 6 and 2 add to give 8, we're going to rewrite the middle term as, take the 8x, write it as a positive 6x and a positive 2x, leaving the same variable on the end of it, but just replacing the 8 with a 6 and a 2, which basically means now, instead of a polynomial with 3 terms, the end of step 3 is I now have a polynomial of 4 terms. And so our fourth step at this point is use something we learned at the beginning of the factoring chapter, and that was to now do what's called factor by grouping. Factor by grouping. And the way that works is to simply take the 4-term polynomial, split it down the middle, alright, so that you got 2 terms on the left and 2 terms on the right, and then look at the first 2 terms and try to factor those. Here we can factor out a 3x, which leaves x plus 2. Then try to factor the second 2 on their own, there we can pull out a positive 2, which leaves also x plus 2. And since we now have the same binomial factor here, using the factor by grouping technique, we can rewrite this by factoring out the x plus 2, and our other binomial would just be the 3x plus 2. And so we have here now at the end, this is the final factored result of the original trinomial. And you can even check it now by doing a FOIL on it and make sure you get the original trinomial. So that's one example of the AC method. Let's do another one. Now let's use the AC method to factor this trinomial. So using the 4 steps we just talked about, step 1 would be to say multiply the value a, which in this case 5, times the value c, which is the negative 6. That would be 5 times the negative 6, which would equal negative 30, bringing us to step 2, which says now go ahead and try and find 2 other numbers that also multiply to give a negative 30, but add to give the middle value, in this case that negative 13. So multiply to give negative 30 and add to give negative 13. And again, if these values don't exist, then it just does not factor. But we actually can find numbers that satisfy this. Turns out a negative 15 and a positive 2 will multiply to give negative 30 and add to give a negative 13. And again, they're the only 2 that are going to work. So if you find 2 that work, you found the only 2 that work. So this brings us to step 3. It says now that you found those numbers, rewrite the original trinomial by leaving the first term alone, 5y squared, leave the last term alone, the negative 6, but in place of the negative 13y, take the 2 values you just found in step 2 and rewrite the middle term by taking the negative 13y and writing it as the negative 15y and a positive 2y. All right, now, what if you'd put the 2 first and then the negative 15y next? Actually, it would not matter. You would actually end up getting the same answer. You can even try that if you want to. So let's go ahead now and go on to the 4th step, which is now that we have 4 terms, let's factor by grouping. So splitting this down the middle, let's look at the first terms and say, what can I factor out of those? I can factor out a 5 and a y, leaving y minus 3. Go to the second pair. So what can I factor out of that? Well, actually, I can pull out a positive 2, which also leaves y minus 3. And since we now have the same binomial factor, using the factor by grouping technique, we get as our factors, y minus 3 is one of them, and then these 2 terms here, the 5y and the plus 2, make our other binomial. And so once again, we have factored the original trinomial using the AC method. So it's not really a terribly difficult method. You're basically just in step 1 multiplying a couple numbers. In step 2, looking for a couple values that multiply to give that, add to give something else. In step 3, taking those 2 numbers and replacing them with the original middle term. And then step 4, small factor by grouping. The only step that may actually cause any length of time would probably be this step here where you're looking for these numbers, because sometimes the numbers can get a little bit bigger. But it's just a matter of playing around with them to see if those numbers do exist or not. Let's do a last example here of the AC method using a trinomial with slightly larger numbers. Let's take the trinomial 14n squared plus 17n minus 6 and see if we can't factor this. So the first step, of course, is to multiply the value a times the value c. A would be the 14. C is the negative 6 at the end. So multiplying those, I get 14 times the negative 6, which is actually a negative 84, bringing me to step 2, which says now what you're trying to do is find 2 numbers that multiply to also give negative 84, but must add to give that middle value positive 17. And so we try and look for these numbers. And because these values are a little bit larger, it might take a little bit longer. One thing to keep in mind is since they have to multiply to give a negative 84, one number needs to be positive and the other number needs to be negative. Also, since the sum is a positive 17, then the larger one needs to be positive, and they also need to be about 17 away from each other, which when you work with those restrictions, you can boil it down to a positive 21 and a negative 4. Now that might take you a few minutes to find. You're not expected to find those right away, but the more you play around with these, the easier it'll get. And sure enough, when you multiply those, you get negative 84, and when you add them, you do get a positive 17. So we found the two numbers, bringing us to step 3, where we rewrite the original trinomial as 14n squared, but in place of the 17n, we write a positive 21n and a negative 4n, and end up with a negative 6. And then the fourth step is, of course, the fourth step is to do the factor by grouping. Split it down the middle and ask yourself, what can you factor out of the first two? We can factor out a 7 and an n, which leaves 2n plus 3. Looking at the second binomial here, the second two terms, looks like we can factor out a negative 2, which also leaves 2n plus 3. We wanted to factor out the negative with the 2 because, remember, we do want these to look the same. And now, doing the factor by grouping technique, we can factor out that 2n plus 3, which leaves the 7n minus 2 for our second binomial, and we are done. Can check that with a FOIL, but that is the factorization of the original trinomial. So a brief description and a few examples of the AC method. Hope this helps.